The light from afar, a cosmic discovery on Proxima Centauri b. In the early hours of a chilly morning in 2025, a team of astronomers huddled around a bank of computer screens at NASA's Goddard Space Flight Center in Greenbelt, Maryland. The room buzzed with a quiet intensity, the kind that precedes a moment of history. Data was streaming in from the James Webb Space Telescope, JWST, humanity's most advanced eye on the cosmos, and what it was revealing was nothing short of extraordinary. Beams of light, brilliant and pulsating, appeared to radiate from a location millions of light years away, a sight that defied explanation. But it was the telescope's subsequent focus on a much closer target, Proxima Centauri b, the nearest known exoplanet to our solar system, just 4.24 light-years away. That would ignite a firestorm of speculation and wonder. Could these bursts of light, resembling the glow of a sprawling urban metropolis, be the first tangible signs of an alien civilization? A new chapter in the search for life. For centuries, humanity has gazed at the stars and wondered, are we alone? The question has fueled countless stories, scientific inquiries, and dreams of contact with beings from beyond our world. From the rudimentary telescopes of Galileo to the radio searches of SETI, the quest for extraterrestrial life has been a constant thread in human exploration. Yet, despite decades of effort, evidence remained elusive until now. The James Webb Space Telescope, launched in 2021, had already revolutionized our understanding of the universe with its unparalleled ability to peer through cosmic dust and capture infrared light from distant objects. But this discovery, announced to the world in June 2025, was unlike anything before it. The initial detection came during a routine scan of deep space, part of JWST's mission to study the formation of stars, galaxies, and planets. Astronomers noticed an anomaly, beams of light, sharp and structured, emanating from a region far beyond our galaxy. At first, the team suspected a natural phenomenon, perhaps a quasar, a pulsar, or some other energetic cosmic event. But as they analyzed the data, the light's characteristics didn't match any known stellar or galactic signatures. It was too organized, too rhythmic, almost as if it were deliberate. Intrigued, the team redirected the telescope's gaze to a more familiar target, Proxima Centauri b, an exoplanet orbiting the red dwarf star Proxima Centauri in the Alpha Centauri system, our closest stellar neighbor. What they found was astonishing. Brilliant bursts of light flickered from the surface of Proxima Centauri b, visible even on its dark side, where no sunlight should illuminate it. The pattern was uncannily similar to the glow of city lights on Earth. Think of the golden haze of New York or Tokyo as seen from space. The scientific community erupted in excitement. Could this be the hallmark of an alien civilization, a metropolis of unimaginable scale and complexity thriving on a distant world? The discovery rekindled a fervor not seen since the 1970s, when the Viking landers searched for life on Mars. For NASA engineers, astronomers, and the public alike, this was a moment of profound possibility. Proxima Centauri b, a world of mystery. Proxima Centauri b, discovered in 2016, has long fascinated scientists. Orbiting a red dwarf star, it lies within the habitable zone, the region where temperatures might allow liquid water to exist, a key ingredient for life as we know it. The planet, roughly 1.17 times the mass of Earth, completes an orbit every 11.2 Earth days, a dizzying pace compared to our year-long journey around the Sun. But its proximity to Proxima Centauri, a cool and dim star, comes with challenges. Red dwarfs are prone to violent flares, bathing their planets in intense radiation that could strip away atmospheres or sterilize surfaces. Yet, Proxima Centauri b has endured, and now, the JWST was revealing something extraordinary about it. David Kipping, an astronomer at Columbia University and a leading expert on exoplanets, described the planet as uniquely complex. Unlike many rocky worlds that simply absorb sunlight and re-emit it as infrared radiation, Proxima Centauri b exhibited unusual behavior. Its interaction with its star was dynamic, shaped by a tidal lock, a phenomenon where one side of the planet perpetually faces a star, basking in constant daylight, while the other remains in eternal night. This creates extreme temperature contrasts. The day side could scorch at hundreds of degrees Celsius, while the night side might plunge to frigid lows, potentially freezing any atmosphere or surface features. The lights detected by JWST were most intriguing on the dark side, where no natural illumination should exist. The telescope's sensitivity to infrared wavelengths allowed it to pick up these faint glimmers, which fell within a narrow frequency range, distinct from the broad spectrum of starlight or the glow of heated rock. This isn't just reflected sunlight or thermal emission, Kipping explained in a press conference. The pattern suggests something structured, possibly artificial. We're not saying it's aliens, but we can't rule it out yet. The possibility sent ripples through the scientific community, sparking debates, hypotheses, and a renewed urgency to understand this enigmatic world. The power of the James Webb Space Telescope. The James Webb Space Telescope, a marvel of engineering, was uniquely suited for this discovery. Unlike its predecessor, the Hubble Space Telescope, which primarily observed visible and ultraviolet light, JWST excels at capturing infrared radiation. This capability allows it to peer through cosmic dust, study the heat signatures of distant objects, and observe planets even on their dark sides. Positioned at the L2 Lagrange point, 1.5 million kilometers from Earth, JWST orbits the Sun in sync with our planet, providing a stable platform for its observations. Its 6.5-meter mirror, coated in gold to enhance infrared detection, and its suite of instruments, cameras, spectrographs, and coronagraphs, make it a powerhouse for exploring the universe. For Proxima Centauri b, JWST's infrared prowess was critical. The telescope detected thermal emissions from the planet, offering clues about its surface and atmosphere. If Proxima Centauri b has an atmosphere, scientists reason it could redistribute heat from the blazing day side to the cold night side, moderating the extreme temperature swings. The bursts of light, however, were another puzzle. Natural explanations of volcanic activity, auroras, or bioluminescence were considered, but none fully matched the data. Volcanic glow would be diffuse and constant, not pulsed. Auroras require a strong magnetic field and charged particles, which might not align with the planet's conditions, and bioluminescence, while fascinating, would demand a scale and intensity unprecedented in nature. The telescope's ability to observe Proxima Centauri b's 11.2-day orbit in detail was a stroke of luck. By tracking the planet's day-night cycle, scientists could study how the light emissions varied over time. Was the glow consistent, or did it flicker in patterns suggestive of activity? The data was tantalizing but inconclusive, prompting NASA to schedule additional observations. "We're just scratching the surface," said Sarah Seeger, an astrophysicist at MIT and a pioneer in exoplanet research. The James Webb Space Telescope is giving us a window into Proxima Centauri b secrets, but we need more time and data to understand what we're seeing. The atmosphere, a key to habitability. If the lights were indeed artificial, the implications hinge on Proxima Centauri b's habitability. Could this planet, so close yet so alien, support life? The next step was to analyze its atmosphere, if one existed. JWST spectrographs, instruments that break light into its component wavelengths, were ideal for this task. When starlight passes through a planet's atmosphere, certain wavelengths are absorbed by gases like water vapor, carbon dioxide, and methane, leaving a chemical fingerprint. These molecules are critical indicators of habitability and, in some combinations, potential biosignatures of life. The telescope excels at detecting water vapor, carbon dioxide, and methane, but struggles with free oxygen, a molecule strongly associated with biological processes on Earth. Oxygen is tricky to spot because it doesn't absorb infrared light as distinctly as other gases. However, JWST can search for ozone, a byproduct of oxygen that might hint at a robust atmosphere. If we find water vapor and methane in specific ratios, or ozone in abundance, it would be a strong clue that something, maybe life, is at work, Seeger explained. But we must be cautious. Geology, not biology, can produce these signals too. The extreme temperature gradient on Proxima Centauri b pose a challenge. If the planet has an atmosphere, the day side might be a blistering furnace, while the night side could be an icy wasteland. A thick atmosphere could mitigate this, circulating heat via winds or convection, much like Earth's atmosphere tempers our climate. JWST's thermal maps showed variations, suggesting some heat transfer, but the data was preliminary. Researchers needed more observations to model the atmosphere's thickness, composition, and dynamics. Was it thin and tenuous like Mars or dense and cloudy like Venus? Each scenario would shape the planet's potential to host life or a civilization. The alien city hypothesis. The idea of city lights on Proxima Centauri captured the public's imagination. Social media buzzed with speculation, from alien megacities to advanced energy grids. Scientists, however, urged caution. We're trained to exhaust natural explanations first, said Kipping. But the structured nature of these lights, their narrow frequency, and their appearance on the dark side make this a tough puzzle. If artificial, the emissions could stem from technology, perhaps vast arrays of lights, energy reactors, or even reflective structures designed to harness starlight. An alien civilization, if advanced, might have adapted to the planet's harsh conditions, thriving in ways humans could barely conceive. The distance of 4.24 light-years added a layer of intrigue. The light we see today left Proxima Centauri b over 4 years ago, a snapshot of past. If these were artificial lights, how long had they been shining? Had a civilization been signaling or simply existing? For centuries, waiting for our technology to catch up? The possibility was humbling. We're seeing history in real time, said Lisa Kaltneger, director of the Carl Sagan Institute at Cornell University. If this is a civilization, it's been there longer than we've had telescopes to notice. Skeptics pointed to alternative explanations. Could the lights be reflections from icy surfaces, amplified by some quirk of the planet's geology? Or perhaps a rare atmospheric phenomenon, like glowing plasma triggered by stellar flares? Each hypothesis was tested against JWST's data, but none fully account for the rhythmic, concentrated bursts. The scientific method demanded rigor, yet the allure of the alien city hypothesis was undeniable. It was a rare moment when the line between science and science fiction blurred, and the world held its breath, the limits and the future. Despite its power, the James Webb Space Telescope has limitations. It can observe only a handful of nearby exoplanets with precision, and its ability to detect faint signals is constrained by time and distance. For a deeper look, astronomers are turning to complementary tools. Ground-based observatories, like the extremely large telescope ELT, set to begin operations in 2027 in Chile's Atacama Desert, promise unprecedented detail. With a 39-meter mirror, the ELT will capture sharper images and more precise spectra, probing Proxima Centauri b's atmosphere for signs of life with greater sensitivity. Future space telescopes are also on the horizon. Scientists are developing instruments with advanced starlight-blocking technologies, such as coronagraphs and star shades. A coronagraph, integrated into a telescope, masks a star's glare, allowing the faint light of planets to shine through. A star shade, a flower-shaped spacecraft, flies thousands of kilometers ahead of the telescope, casting a shadow to block starlight. These innovations could reveal planets in the habitable zones of stars, where liquid water and life might exist. The precision required is staggering. A star shade must align to fractions of a millimeter across vast distances, all while enduring the harshness of space. These technologies aim to overcome a fundamental challenge. Stars outshine their planets by factors of millions or billions. Detecting a planet's reflected light is like spotting a firefly next to a searchlight. Yet, the payoff could be monumental. If biosignatures, combinations of oxygen, methane, or water vapor, are found, they might suggest biological activity. Direct imaging, enhanced by adaptive optics to correct for atmospheric distortion, could even map a planet's surface, revealing continents, oceans, or, dare we dream, cities. A new era of exploration. The discovery on Proxima Centauri b is a turning point. The James Webb Space Telescope, with its infrared gaze, has ushered in a new era of cosmic exploration, peeling back layers of mystery about distant worlds. Each dataset brings humanity closer to answering the ultimate question: are we alone? Researchers are planning follow-up observations, modeling the planet's atmosphere, and refining techniques to distinguish natural from artificial signals. The excitement is palpable, but the work is meticulous, a dance of patience and precision.